Alright, so here we go. Today, in our last video we talked about limits graphically. In these next two videos, the first one today we're going to talk about limits at a point algebraically, and then evaluating points using a table or a graph. We talked about the graph, we're talking about the table in the next video. Okay? So there are a couple different ways we can evaluate limits. Alright, first of all, for finding limits, our methods for finding limits, one of them, first one, substitution, the easiest one we can do. Substitution, where if I have this limit, some limit as x approaches some number c of f of x, substitution meaning I take f of c, I plug in c into my function for x. Well, if I figure out what f of c is, let's say f of c, what is f of c? I don't know. What if f of c equals something L, like some actual number L, then our limit is going to equal that same thing. We can simplify using algebra. And how we're going to do that is by factoring. First factor, factoring first, and we're also going to talk about multiplying by the conjugate. Okay, this we'll talk about in our next video. This we already did in our last video. All right, so let's talk about substitution. Limits at a point. First, in substitution, plug in whatever your a value is, okay, as x approaches a. All right, there are four different cases that we're going to talk about. Our first case is if I have a number, just a flat number like 4, or some fraction like 4 over 5, then our limit, after I substitute it in and I get that, is going to equal whatever that number was. So if I take f of a, and it spits out a number, then that's my answer, and I just stop. Okay. If I take f of a, and it spits out 0, or it spits out 0 over some number, then my limit is just 0. It's just 0. Okay. If I substitute an f of a and I get some number divided by 0, well, we know that we cannot divide by 0, and that means I'm going to have an asymptote. And if I tried factoring and all that stuff, if I have my asymptote, okay, I'm going to look at my graph. So we need to look and determine where my function is going. My function could be going toward negative infinity. It could be going, or positive infinity. It could be going towards negative infinity from the right and the left. Those are the options here. For a function. And we'll do one of those. We'll do one of those. Okay. Lastly, our last case, if I get 0 over 0, then that tells me I need to keep on trucking. Keep going. Just keep swimming. Alright, and that means I'll probably have to do some algebra. Okay, whether I factor or I use the conjugate. All right, let's talk about each of these cases, and I'll refer back to them when we approach them. Okay, here we go. So, substitution. Plug it in. Plug 2 in for my x values. So, 5 times 2 minus 3 over 2 plus 7. 5 times 2 is 10. 10 minus 3 is 7. 2 plus 7 is 9. So, I have a number over a number. Then the limit is 7 nines. The limit as x approaches 2, use 7 over 9. My y values approach 7 over 9. All right. Substitution. Negative 5 squared plus 6 times negative 5 minus 3 all over negative 5 squared minus 5. Well, negative 5 squared, I get 25. Minus 30 minus 3 all over 25 minus 5. Remember, when plugging this in your calculator, must use parentheses. I'll also give you a negative 25 here, which is incorrect. 25 minus 30 is negative 5, minus 3 is negative 8, over 25 minus 5 is 20, which simplifies to negative 2 over 5, which is again a number over a number. So we're done. Therefore, the limit as x approaches negative 5 is our y values approach negative 2 over 5. All right, let's plug it in. Here we go, plug in 2. Well, obviously on the bottom we're going to get 0, but I got to check the top. 2 squared plus 3 times 2 minus 10. 4 plus 6 is 10, minus 10 is 0 over 0. Uh-oh. 0 over 0 means we have to keep going. 0 over 0. Keep going. Don't you stop. So to keep going, I'm going to rewrite. Yes, I must include this. And then I'm going to factor my numerator to x plus 5 and x minus 2. Uh-oh. And x minus 2 down here. Well, it looks like I'm going to have a hole at x equals 2. All right? Because why? Because these two factors cancel. So I'm looking at the limit as x approaches 2, and I'm only concerned about this x plus 5. Because the x minus 2's are our hole. Plug in 2, I get 2 plus 5, which gives me 7. So if you thought about this graphically, 1, 2, 1, 2, 3, 4, 5, 6, 7. I'm going to have what? Since there's a cancellation here, I'm going to have a hole at 2, 7. And then everything, the left and the right are going to do something different. Okay. However, since there's a hole there, my limit can still have a value there. All right. I can still have a value at that limit. As x approaches 2, my y values approach 7, but they're not equal to 7. That's what limits do. It allows us to evaluate that part of our function. Yes. Let's keep going. Did I skip anything? No, I did not. All right, so I have x minus 4. Oh, I did skip. That's why I was so confused. So I have x squared plus 4x minus 5, or x squared minus 25. Substitution. 5 squared plus 4 times 5 minus 5 all over 5 squared minus 25. Well, I have 5 squared, which is 25, plus 20. 25 plus 20 is 45, minus 5 is 40. And then I have 25 minus 25, which is 0, which means I have an asymptote, which means I have to graph it. So I'm going to graph using my graphing calculator. Again, unfortunately, I do not have one. Not sure we got cut off. I want to graph using my graphing calculator. Unfortunately, I don't have one. However, I'm going to look at this graph using Desmos. Again, make sure you're plugging in using parentheses. So if we look at this function here, all right, at x equals 5. Whoops, I want to zoom in a little bit more. At x equals 5, what's happening? Well, from the left, I'm going to negative infinity. And from the right, I'm going to positive infinity. Well, if my left and right limits do not match, okay, that means what? That the function, the limit, does not exist. All right, let's say my function looks like this. This is 5. All right, if my function, both sides looked like that, I would say positive infinity. If the left and the right limits looked like this, I would say negative infinity. So positive and negative infinities are acceptable answers if the left and right limits match. Okay? Okay. Here we go. 4. Okay. Okay. All right. Try that again. 4 minus 4 over 4 squared plus 10. Well, 4 minus 4 is 0. 4 squared is 16, plus 10 gives me 26. So the limit is 0 since it's not 0 over 0. Then I don't have to keep going. Okay, let's try this one. X squared minus 4x minus 21. And now this says from the right, okay? Now really, that doesn't really matter, all right? It does and it doesn't. It doesn't matter in the sense that if our left and right limits match, if this limit exists, then that tells me that the left and right limits will be the same, okay? So let's see if that happens, all right? So if I plug in negative 3, negative 3 squared plus 7 times negative 3 plus 12. What do I get? I get, I get 0 on top over 0. So I got a kg, keep going. Keep going. So to keep going, we said the first thing we want to try to do is factor. Factor the top, I get x minus 7 times x plus 3. Factor the denominator, I get x plus 4 and x plus 3. So that means these cancel. I have a whole at negative 3. So I'm really concerned about evaluating the limit of x goes to negative 3 from the right of x minus 7 over x plus 4. Negative 3 minus 7 is negative 10. Negative 4 plus 3, negative 3 plus 4 is negative 1, so our answer is negative 10. All right, let's keep going. I want you to substitute in, see if you get 0 over 0. Here we go. All right, so here I got 0 over 0, which means I need to keep going. Can't really factor here, so what am I going to do? I'm going to multiply by the conjugate. Now, I determine the conjugate by where the square root is. The square root is in the top, so my conjugate is the square root of x plus 2. If the square root is in the bottom, I'll use that conjugate. All right, evaluate the limit as x goes to 4. Multiply square root of x times square root of x is just x. Positive 2 root x minus 2 root x, those will cancel, and then I'll have minus 4. I'm just going to leave this, x minus 4, and not actually multiply it, save ourselves some times. There's going to be a reason for that, and I think you're starting to see it. These x minus 4s will cancel. So technically, remember, there's a 1 there. 1 over root x plus 2. Substitute 1 over root 4 plus 2. Well, square root of 4 is 2, so it's 2 plus 2, which is 1/4, which is my answer. Okay, I do the conjugate to force two perfect squares, like the square root of x and the square root of x gives me x, to get rid of the radical. All right. Last one down here. Okay. Well, if I substitute in 0, I'll get, go ahead, substitute it in again. See what you get. Okay, I got 0 over 0 again. Keep going. So we can't factor this, obviously. Can we factor this? No. So I have to multiply by the conjugate. Remember, the conjugate is determined by the location of the square root. The square root's in the numerator. So I use that as my conjugate. And if I multiply my numerator, that square root sign is going to drop out. I'll have positive 2 root x plus 4, negative 2 root x plus 4, which will drop out. So I'll just be left over with negative 2 times 2, which gives me negative 4. The numerator, I will have x times root x plus 4 plus 2. All right, well, what happens here? Our 4 and negative 4 cancel. Okay, so I have the limit as x goes to 0 of x over x times root x plus 4 plus 2. Well, now this is a 1. Now my x's cancel. Holy buckets, a lot of canceling here. Oh my gosh, I'm running out of time. Oh boy, oh boy, oh boy, pause it. Kind of panicked there. So I'll have the limit, I'll have 1 over root x plus 2. Plug it in, I get 1/4. Alright, this is not always going to happen. Your answer is not always going to be 1/4. Alright. Again, when using substitution, there are these 4 cases. I could have a number. When substitution works, I could have 0 over a number. If I have a number over 0, look at your graph. If you have 0 over 0, keep going.